Hi, my name's Reed Richardson, and I'm here with NuWave Composites. And today we're going to talk a little bit about vacuum infusion. We're going to go over what it is, the materials we use, and then we're going to actually build a part together. So a little bit about vacuum infusion. It's not a new process. It's been around since the 70s, but it relies on the process or the concept of vacuum pressure and atmospheric pressure to pull resin into the part. So the whole idea and difference between closed molding, which is vacuum infusion, and open molding is in open molding, all of your fibers are put in dry and your resin is wet out and applied by hand. In the vacuum infusion process, all of your fibers and everything go in dry, a vacuum bag is put into place, all of the air is sucked out, and then all in one shot, the resin is drawn in under vacuum. So this does a couple things for you. It gives you a much better glass to resin ratio than open molding. You can do much bigger stacks all at once. You end up with a lighter part for a similar strength. So there's a lot of advantages. It's also cleaner. You get less environmental impacts. So there's just many different reasons why people are using vacuum infusion in their processes. So that's not to say that there's not a place for, open mold hand lamination. There's absolutely still great use cases for it. But this is just a topic that a lot of people have reached out to us on for some more information. So we're here trying to provide that. So laid out in front of me, we've got some examples of the tools and materials that are used in vacuum infusion. So on this side, these are typical examples of your materials. Here we have a fiberglass. This is a 1708. It's just a biaxial with mat. This is a Soric. This is a lightweight coring material that you can use in infusion, very conformable. Then we have outside of your standard reinforcements, which would be your glass and your core, we've got all of the infusion specific products. So this right here is a flow media. So what this does is it helps the resin flow across and through the part. Without it, the resin flows very slowly through the glass, like it's just wicking through the fibers. This allows it to travel very quickly over top, saturate down through all the laminate, and get everything there. So one other detail on the back of this, there's actually a plastic film here. It's a perforated release film. So what that does, when you put this down on your part after the infusion happens, this will peel away. So this does not stay in your part. All that excess resin and weight comes out. So we also have our vacuum bag, which does exactly that. It allows us to seal the part tight, pull out all the air, and it's kind of like the core concept of vacuum fusion. Additionally, on the flow side, we have this. This is an Enca channel. So what this does is it allows for much rapid resin transfer. So you can see here, we've got a nice cross section. You can see it's much thicker. They serve the same purpose, but this one's very thin, like a capillary action, and this one's more higher volume, like a vein. The last component really of your resin feeding would be your spiral hose. This is gonna act like the artery system of it. This is typically what'll feed the part. All the resin will travel very fast and quickly through this and allow it to spread out through the part. So additionally, we've got our tacky tape. This is a sticky double-sided tape that allows you to seal your bag to your mold and pull that vacuum. We've got one other piece here. This is I'll call it a vacuum tail. We'll talk a little bit more about this and you'll see how it's used later. But what this does is it allows the air to travel through the part and vacuum to move through, but it doesn't allow resin to travel very quickly. So what this is going to do, it's going to help slow that resin front and keep a lot of resin from coming out of your part once the infusion's done. Then we have our standard poly tubing, which this will carry the resin into the part and pull the vacuum out. This is just a standard, this is a 1/2-inch ID tubing. You've got a nice little plastic disposable ball valve. You can get away without these. You can pinch the hose or use clamps, but these are really nice, user-friendly. They're pretty cheap when you buy enough of them, and they just work really, really well. Then we've got a few tools. These little electric scissors, we get them on Amazon. We can post a link below, but these are awesome. Really, really great for cutting all your fabric. Good to have a pair of manual scissors around for cutting some hose and stuff, but these are absolute lifesaver. They cut through all different types of materials from lightweight 1708. They'll cut carbon fiber. They'll cut really heavy, thick laminates, like 50, 60 ounce material. So awesome product. This is just a little roller, and what it's gonna do is we're gonna use that to press down our tacky tape. Just does a good job of getting good pressure to seal it to the mold, and we can flatten out any little wrinkles and ripples. Then we've got our spray adhesive. This one is a 3M71. This is one that we like the most. It's specifically designed for composite use. So great product. It's got a little green tracer in it so you can see where you've been. And then last but not least, PPE, gloves, safety glasses. You can use a respirator or like a light face mask just for some of the aerosols and maybe some dry fiber in the air. But one nice thing about vacuum infusion is you don't have that massive amount of resin or aerosol in the air from the resin. It's a lot cleaner process. You can do it honestly, you can do the process in a t-shirt. You don't have to. You can still put on a suit and keep all the itchiness and everything else off you, but it is a very clean process. So that's one other reason a lot of people like it. So lastly, moving in, this object, this is what we're going to be making today. This is an example of a nice lightweight infused part. This is actually non-marine related. This is a gas bonnet used in electrical systems. They actually pressurize it with a non-reactive gas where there's a couple, 10,000 volts going on in there. So lots of different applications for composites outside of marine. We do a little bit of everything. So with all that said, we can bring our mold over and we can start putting some fabric down, and I can show you how all these materials should be applied, little tips and tricks as we go for all the different materials, and really see how they get used and what their best applications are. And one note before we get into it, there's so many different ways to do this. There's all different types of materials and preferences and brands and all this. So there's many different correct ways. This is the way that I've found and we found that works really well, gives us consistent results, and is pretty easy and user-friendly and easy to teach. Okay, so here we have our mold. It's already been gel coated. All of the release agent was applied before that. So this thing is ready to go. So our first steps are gonna be putting in our first layers of fiberglass, right? So we have all of this pre-kitted. We've got one of the services we offer is glass and pour kitting. So really helps, as you'll see, putting together this part. Everything goes a lot faster when you don't have to go out and measure and keep cutting and all that. So this laminate schedule just calls for this first layer is a 1708. So one thing that I want to really note on is the use of the spray glue. Although it does break down within the resin, it does not come out of the part. So less is more. You just want to put enough in there to keep this tacked down. And really the vacuum is going to do a lot of work to pack that glass into the corners, as long as it's not glued down too tight. If you got too much glue, the fabric can't move and the vacuum can't do its job, and you'll end up with what's called bridging, where the material's not all the way in the corner. You can end up with excessive resin and heat and all of that. So really, it's just small amounts, light misting, just enough to keep that in place. And really, your first plies are going to be probably your more important ones to get your glue down. After that, you can be a little bit more sparing with it. So as you can see, all we're doing here is just using our hands to pack some of this into the corners, right? And really, this part's a little interesting because we've got this channel here, so we're gonna have to do some relief cuts to give us some room to lay this down. So again, as you go, pack the corners nice and tight right in here. There are some nice little roller tools that they make that really help to roll that material in. But on a simple small part like this, not 100% necessary. So really the goal here is just to get that material laying down nice and just working bit by bit, corner by corner, to get things where you want them. Another nice thing about the infusion process is that you're not on a timer, right? Where with the open molding, you've got the resin is catalyzed when you're working with it. So you gotta get the job done before, when the resin tells you to. Here, you've got the ability to, stop. You can take a break if you need to. We can do really whatever you want to get that down in the right amount of time. So this is working along. You can see these little scissors doing a great job cutting everything for us. Nice and smooth, nice and quick. It is worth noting that all of these relief cuts do weaken the material along that axis. So this is not a very structural part. It's really, not taking a lot of load. It's really just a lightly pressurized chamber. So and the geometry, this nice ring adds a lot of strength on its own. So if you were building a more structural part, all of these seams, you'd really need to come back and put another layer or some additional plies in there to overlap and recoup some of that lost strength. But what we're going to end up doing when we put our second layer on is alternating that seam line. So instead of it being in the same spot every time, you want to stagger those kind of overlaps and stagger those seam lines so that you end up with a more uniform part. So thankfully on layer 2, we actually don't have to worry about that because we are filling in those voids with some core material. So those little wedges will fit in there, and then we'll be moving on to the next layer. So again, nice light misting. Next material, this is a Soric TF. It is the lightest and thinnest of the Soric materials, and that is just going to fit right in here to our bottom of this cavity. So it's a great material. It adds a little bit of thickness, and because of the very small cell structure of it, it doesn't print on there. It's actually commonly used as a print blocking material, which we've talked a lot about all the benefits of Infusion. It does have its downsides. You can struggle with print because all of the heat of the infusion process can take that that fiber, and as the resin heats up and shrinks, you can get fiber print, you can get general heat distortion, you can get all types of stuff. So typically we'll end up using some fabrics or print blocking materials that'll help mitigate that. You can also use thicker skin coats, which is like your hand laminated first layers, right? You'll notice this part does not have a skin coat. So when you're working with Infusion, especially very small parts like this, you have the benefit of being able to go straight to the gel coat, as long as you're within your bond window for your gel coat. So again, you can see we're just flying through these layers here with our Infusion. Again, we're just layer number 2, stacking it on in. And all we got to do here is cut a couple relief cuts in there. You can see I'm not using a lot of glue. They make the glue in a big canister, like a propane cylinder with a big wand attached to it. And yeah, you save some money on your price per pound, but you end up putting down a lot of glue, which you end up putting down way more than you ever would in a can, which is not good for your part. And it's not any savings that you had are gone because you're filling your part up with glue. Again, these scissors, can't recommend them enough. With a rechargeable battery. They got replaceable cutter heads on them. They do eventually dull out, but man, they last quite a while and put in some heavy work for us. So there we go. So really our bottom cap laminate of that is done, and we're really just going to repeat the same process with the same materials for the sides. So we've got 2 more layers of 1708 and then 1 layer that goes in the middle, that Soric. So we're just going to get these ready. Again, we're going to be doing a lot of relief cutting here. This is going to fit around, and we'll snip it as we go. So we'll see. We'll do a nice even misting. This stuff is the only time when you probably do better from either wearing a respirator or having good mass, and one more reason to use less of it. It does have some fumes to it, so recommend either wearing a mask, respirator, or working with. We keep lots of good fans, and we're in Florida here, so we got the luxury of of being able to keep the doors open pretty much year round. So a little jam. Here we go. So again, if this were the only layer, we would come in and put some more reinforcements here, but because we have one more layer going on shortly after this, we'll be able to just stagger these overlaps and just not cut them in the exact same spot. And voila. And again, not a structural, very highly structural part, so not a huge concern. One other thing you'll notice on the 1708, this is a matte back product, meaning you've got the chop strand mat on the back. Not necessary for infusion. That's typically used on a hand open molded part, and what it does on the open molded part is it gives you a good bond to the previous layer. Kind of acts as like a little bit of a spongy material that'll give you that good bond. Not needed on infusion. We're using it here because it's just readily available, builds a little thickness, adds a little weight, which is good in this product. But typically, you can use non-matte back parts. So you could use a 1700, right? Which gets rid of that 08, that, basically 1 ounce mat on the back. So the infusion process can really be a labor savings depending on the part, everything, how you're building it, your training of your workforce, and all. But there are some downsides to it. You have all of the consumable materials like your bag, your hose, and everything. And if you don't have a good, well-trained team, you can lose a lot of time on bagging. But that's it's just really part of the learning curve and part of the process. Where the process can really shine is when you need the lightweight and you have a large part. It's most common on bigger pieces because you start to see the savings come back. The bag is a much smaller part of the build. All those hoses kind of get factored in. If you're building a 25, 30-foot boat, that all kind of disappears pretty quickly. But even on a part like this, we like it. There's a lot of intricate detail on this part. We've got molded in countersinks for all the screws, so not having to work a skin coat around all of those edges is really nice. There we go. So making some progress, only a couple more layers left, and we'll be getting ready to put the bag on. So that's all right. So our last final layer after all our reinforcements are in is this flow media. So this is again what's going to allow the resin to flow across and through the part and fill it out with resin. So it's basically applied in the same way, a light misting of blue, and then we'll just pop it down into place. So this also allows all of our consumable materials like our anchor channel and our hose and everything. It'll also allow that to be put right on top of this and come right back out. There are scenarios where you can, not use the flow media, but when everything else that you put in, like your spiral wrap and anchor channel and everything, you will have to put down some peel fly or a different type of release film to be able to get those pieces out. So one other super important piece of information when you're doing these parts is what's called a resin break. So as your resin's flowing through your part, it's going to flow very quickly along your flow media, and you can actually have a differential in flow from the top of the laminate to the bottom. This is even more common with cord laminates. This is, what we'd call a single skin laminate, where it's all glass pretty much. The Soric is so small that it really doesn't count. But what this resin break between your flow media and your vacuum line does is it allows the resin on the top and bottom to converge. So the ones on the bottom that's moving a little slower, it lets it, kind of catch up, and that'll keep you from having any dry areas underneath. So what I typically use as a general rule of thumb on these parts is I'll stop my flow media right around where my part would trim. So you typically have a little bit of extra reinforcement as we come along. You got to have a flange and some trim offsets. So typically I'll just stop it pretty much where the part trims. So on this case, this is like, we're going to trim somewhere on this vertical surface. So that's pretty much where we're going to halt our flow media. I'm going to come in with one more little strip to kind of help guide this. One thing about the flow media is because it is not a fabric, stitch fabric, it's really a plastic. You get very, I'll call it almost zero drapeability, where it will conform to the part. So you end up having to do a lot more relief cuts than you would with pretty much any other glass fabric. So again, this stuff's pretty forgiving. If you miss a little spot of the flow media, it's not going to be the end of the day. The resin will still flow around it. So, but if you can, cover up most of it. Well, honestly, we'll probably be fine right here, but I'm going to add one little strip because, like anything, a little bit of insurance is probably better than not having any at all. This is such a small part where we're only going to have one resin feed line, but on larger parts, you end up having lots of hoses and lots of inlet ports and a lot more time and labor and everything sunk into a part. So, you want to make sure that part's going to actually work for you and not fail. So in those scenarios, I always err on the side of caution and say, you know what? Put in a little bit more feed lines, put a little bit more anchor channel, just do a little bit more so you feel confident that this part's, gonna succeed, not due to anything silly like not having enough feed lines. Hoses are cheap. Labor and time and materials and everything are not. So that's my one other little pro tip on that. So another material we talked about earlier, this is anchor channel. This is going to act as one of our main resin capillaries or veins that's going to help move resin throughout the part. So we're basically going to make a little T out of this. That's going to go here and here. On a part this size, not totally necessary, but again, it's going to be good for you to see how this works and how it helps move resin through the part. You could, we've got good gel time on our resins to be able to do this part without it. But again, a little bit of cheap insurance and helps make things move a little smoother, feel good. So we're gonna do the same kind of thing here, put another branch, and just make sure that these pieces are touching. If there's a gap between them, they're basically not serving their purpose, right? It's like a electrical wire. You gotta have it there for the current to flow. So without them touching, it's just decoration. So So once we finish up these, then we're basically going to put in our teat, which is going to act as our resin inlet and allow us to puncture through our bag and get the resin into the part. It's also a good habit to get into to making sure you have uniformity. See, these are all cut at roughly cut at the same height. So that's going to help make sure that, you know, you don't get resin moving too quickly on one side of the part and very slowly on the other. Once you do a few infusions, you start to kind of understand how the resin's going to flow through the part. This, you know, it's going to move through the areas of least resistance. And, you know, when you have more fabric, you're going to have a little bit more resistance, more time. There's certain cores that have grooves that can help speed up flow, but for the most part, it's going to be driven based on the amount of glass that's in there and its proximity to your feed lines, either that spiral wrap or your anchor channel and all of that. So a little bit of that's going to come with some experience, but there's all different types of methodologies of sequential feed versus branch. This is more on the branch side. We can talk about that a little bit more later, but this is a pretty typical setup where you typically have a spiral wrap like this running a distance along the part, and then you would intersect on top of it with this anchor channel. So you'd have this running as a main artery, and then this vein coming off of that, and the flow media acting as capillaries. So that's a very typical setup on a larger part. On something like this, the spiral wrap would be overkill, right? You'd see this, it would be hollow and allows the resin to move incredibly fast, just stepping down in terms of your resistance and speed of flow. So the last thing we need to do before we start getting our vacuum line set up is cut in a spot for our T. I like to cut a little slot in the anchor channel. It helps just keep it upright, keep it from falling over. So that's where our resin's going to enter the part. The next piece that's going to go in is going to be our vacuum line. So for this, we're going to use the spiral wrap, and we're going to use this obviously because it is permeable, right? It's going to allow the resin to the air to go through it and the resin to enter through it. So what we've got here, it's super important that this vacuum line needs to be on the fiberglass, right? If it's not on the glass, if it's out here, you've got no means of transmission, right? Like I said earlier, it's like an electrical line. You got to have continuity for flow. So we're going to do this here. Let's spin this around, make it a little easier on myself, and we'll line these up, and we can cut off a little extra of this. And I like to intersect and have them kind of touch off on one another. Always good to have a standard pair of scissors around. These will do the job on that, but really not your best use for them. Like I said, we'll wrap this around here. Get a nice clean on there, and now we're ready to tack this in place. So you can use a bunch of different means to tack this in place. You can use tacky tape. You can use just like a standard masking tape. Again, this whole area is getting cut out, so it doesn't matter to me if I got some tape that's stuck to my part. So I'm going to go ahead and grab some of that and just loosely keep it in place. One downside to wearing gloves around this is this tape will stick to your hands and your tacky tape like crazy. So for now, I'm going to take these gloves off. A lot of the itchy and dirty work is over for now. So we're just going to put a couple pieces around here, really just to keep this from moving while we get our bag put down. And again, if it falls off the part in a small area, not the end of the world. Just in general, you want to have enough glass on there to be able to keep this wrapped around there. So we're almost set. So the next part is we need to have a way for our resin and our vacuum to exit the part. So we're going to need another T. So you could put a T straight into the spiral wrap, but what that's going to do is once the resin makes it to this line, it's going to be able to pull that resin out of the part. So you've got an opportunity there for it to actually starve the resin out of the part and give you a weaker part. So what we like to do is we use this vacuum tail that we talked about earlier. And what this does is it allows the air to flow through this, but resin flows through it extremely slow. So it's got like a waxy side and a felt side. So the waxy side is going to go gonna go down to the part. So we're gonna put this just like that. It's got a spiral wrap inside it. So we're gonna spray tack that down, and this is gonna kind of hang up in the air, and we're gonna encase that in our bag to keep it away from everything. So you'll see that we've got kind of two methods going on. We've got the spiral wrap here, which is gonna help transfer good flow around the part. And we put that around the part so that if any resin makes it, you know, ununiformly, you've got a little bit more insurance on good flow. You can get away with just using this, but again, this is really more set up like a larger part where you'd put this big spiral wrap and then have this as your last area where your resin flows to. Okay, we just kind of wrap that spiral around this T here and kind of tuck it back in there, and we're good. One thing to note about the spiral wrap, some people always encase it in a peel ply or some other fabric. Some of these sharp ends can puncture your bag. I've only had it happen a couple times, so that's kind of just, I don't bother. But if it's really crucial to you, you know, you can cover those up. They also sell versions of the spiral wrap that already have a peel ply or release film surrounding them. So really at this point, we kind of go through our pre-bag checklist, like all our reinforcements are in, our flow media is set up, our infusion manifold is laid out correctly. We have a means for resin to come into the part through a T, and we have a means for vacuum and resin to come out of the part with this. So everything looks good. Now we can go ahead and get everything laid out for the bag. All right, now we're on to the bagging process. So this is where we're gonna get out our tacky tape like we've seen before. And the technique that I've found to work best, first you'll measure out how much bag you need. Really, you know, if you cut your bag this big, it's not gonna have enough room to go down into the part. So if you take a tape measure and run it along the deepest part of your part, that'd be the maximum dimension in one direction. So as long as you do that and you're this way and that way, you're gonna have enough bag. Always give yourself a little extra room because, you know, you're not gonna pleat it perfectly. So you wanna have more bag than less. So the way that I found that works best is just to run a perimeter around your mold, and then we'll tack our bag down to that and then add all of our pleats. So from here, we'll just come in a little bit on this part. We'll get to this corner. We can actually just fold it right there. Right here. Do another fold. One more fold. Keep that out of the way. And we can just pop it off and lap them right on top of each other. So here we go. So now that we've got that handled, we're gonna get our bag, which we've pre-cut and measured. So you can see here, we've got enough bag here, if you were to hold that there, that this would fit down into the part, right? It's a little tight, but we've got enough. I measured this one by eye. So what we're gonna do is, I like to start right in the corner, and we'll just peel our material back right there and just tack this down. All right, we don't have to press it hard right now. We're gonna come back later and do all of our, press everything down and check for leaks and all that. But I'll go around to each corner of my bag, tear this little wrapper on here, and then tack down all my corners, making sure I haven't folded or twisted my bag along the way. So we're just gonna repeat that 4 times. Peel that back, get our corner, and just tack a little bit right there. One reason to not press it down too hard right now is if you tack this down right now and it's nice and light, you can take it and just pop it real quickly and it'll come back up. Once you press it down pretty hard, it won't be coming back up. So once you've got all of your corners down, we got to take up all this excess material to let it fall into the part. So that's where we're going to be adding our pleats. So there's a lot of different techniques for pleating. This is the one that I've found that works best. My best analogies for it when I teach people is, it's like you're turning the pages of a book, right? So one thing that you can do first is you can kind of pre-plan out your pleats. You can just kind of fake them in and say, all right, how much extra bag do I got? I've got, 6 inches of bag here. So let's do a 3-inch pleat here and a 3-inch pleat here, and that'll be enough. So we'll take our tape, pull out a few inches, snip that, and we're gonna start working our bag along here to the point where we're gonna put our first pleat. Let's say we'll put it right here. Now this is the technique. So I'll peel a little bit back and I'll come in here and I'll kind of fold it over just a hair. That way we don't end up with a little void in the corner. And then you take our bag and we lay it right down on top of that, right? And you can just gently press it there. And then we turn the page of the book. So we turn this side back and then we can peel off this side. And what I like to do here is just take this little bit and fold it over just a tiny bit. Again, that's to make sure that we don't end up exaggerating, but we don't end up doing this where you have a little gap at the top. So I just fold it back ever so slightly. That way we get a little bit of extra there. We make sure we're good. So then there we go, right? See the nice thing there? You can rotate it. I can get my bag seam moving in the right direction. So that's how we've got our pleat. So we're really just gonna keep doing that process. We're gonna work around the whole mold and get this thing nice and sealed off. You can see we're gonna have one more pleat about in this area. So what we'll do is we'll pull on back, keep working along. And in this area, so I call this a closeout pleat. This is where you're closing out one side. Typically, you're gonna be running a lot of pleats. You're gonna be, doing one here, one here, one here. You've got a bigger mold or more bag to take up. So this is a closeout pleat, which kind of ends both sides. So it basically follows the same process where you kind of measure out what you got there and then take a section of this, make it a little long because you want to make sure you got enough there. And we're just going to do the same thing where we open this up, pull this back a little, stick that in, roll it a little with your thumb, and then you can just straighten that out. Instead, turn the page of the book and just lay that right in there. Turn it back this way, peel it off. And now this side, we're going to work from one side over, and that's where we're going to take up all the extra slack there. So instead of coming here and ending up, pulling the bag too tight, when you do a closeout, you work from right to left, not left to right. So now you can see all that little tiny bit of extra there. It's been taken care of. So we're just going to repeat that pleating process throughout all 3 sides, and then we'll be ready to pull the vacuum down. Okay, now that we've got our bag in place, we're going to do our through bag penetrations to go ahead and hook up our vacuum. So we've got our vacuum pump here. We'll go over some different options. A lot of people get really big pumps and really big vacuum chambers. You don't need it. A small pump, as long as it has enough power to be able to pull a full vacuum, will handle parts of almost any size. The bigger pumps will have more regenerative ability, so they'll be able to pull a bag down quicker and overcome leaks and just hold a vacuum better. But a small pump works great. We get one from Easy Composites. They've got a great website. The pump's inexpensive. It works really, really well, and we've done lots of parts with it. So back to this, once we've got our bag in place, we want to kind of mostly just tuck things into place and make sure that we're roughly where we want to be. So this looks pretty good. Here we've got our vacuum line here that we're going to put up into our part. So what we're going to do is just stretch the bag a little bit around this, and we'll take a little bit of tacky tape here, and we will just run a nice little ring around that. So that's what our hose is going to seal against once we poke into this. So on the other end of it, I'm going to set up a little ball valve that's going to go to our pump. You don't necessarily need a ball valve there, but it does help to be able to turn that vacuum on and off quickly if you do need to do a little bit of massaging of the bag as it starts to pull down and go into place. Again, not as needed on the vacuum side because everything that's entering this hose is going to go into the pump. You know, if you have an air leak on this fitting, it's really just going to only affect your ability to do a drop test, which is just testing to see if you do have flow through your part. So now that we've got this set up, I'm going to make a small puncture with a razor knife in the center of this. So really, you just poke it, do a little twist, got a nice hole in there, and then this hose is going to press fit right over top of that barbed tee. You want to get a nice firm press on there and wiggle it. Make sure that tee, you can see it is all the way inside that hose, and that tacky tape does a good job of just sealing itself off really well. So we'll go ahead and turn our vacuum on, and we can see right away this bag is starting to move. And as it's pulling down, you kind of want to start massaging things into place, making sure your bag's in the right spot. This is where you could turn the vacuum off. If you were like, oh no, my chi is falling down or something else wasn't lining up, you can give it a pause. So I'll turn it back on, and right away we can hear some high-pitched squealing, so we know we've got some leaks in our pleats. So I intentionally did not go around and pre-check my pleats, which I usually do, so that we could kind of go look through them together. And really what you want to do is just go in a very methodical way, just round in a circle when you do all your pre-checking. And what you're going to be looking for is any color difference. You see that slight color variance between the light yellow and dark yellow? You can see that's a little channel where that air is going to be able to come through. So really just working through these, pinching them off. At this stage, it's as much of a visual test as it is an auditory one. You'll be able to hear some of them as you go, but really, once you get down to being very close to having a sealed bag, any leaks just become that much louder. So they really make themselves known. So again, it's easiest, just work your way around the part, slow, fold the pleat this way, fold it that way, pinch the base, pinch the top, just keep working along the edges, and you'll find pretty much everything. And it can be pretty satisfying to find that one that's bothering you, because they start squealing and hissing as you get a little closer, a little tighter. Everything gets nice and quiet, and once we feel comfortable that our bag is fully sealed, we'll go look at our gauge on our catch pot over there and do what's called a drop test, which will turn off the flow to the vacuum pump and check to see if we see any drop in pressure, or really an increase in pressure, because we're in vacuum. We're in the absence of atmosphere. Akash. So we can talk a little bit about our vacuum setup here. Here we've got our vacuum pump situated down below. We've got a switch to turn it on. And then we've got this here, which is called a catch pot. What this is going to do is it's going to stop any resin that does leave the part from going down into your vacuum and potentially ruining that machine. So what this does is it provides an intermediary spot for that resin to just go in there. It can kick off. You wax the inside of this. That way, if you do get resin in there, you can just turn it upside down, pop it, and the resin comes out. So definitely wax your catch pots. And then we've got our vacuum gauge. We have a digital one here, which is nice because you don't have to read the dial. There's no questions about it. So here our digital vacuum gauge. This is set up in bar, but there's many different units. So 1 bar is 1 atmosphere, depending on your elevation and everything. One atmosphere is the maximum theoretical, or really, 29 point something, almost 30 inches of mercury. So here we're at 0.95. We can see that this is basically a full vacuum, on our part. So we've reached our maximum level, and then we would perform our drop test. So to do that, we'll basically shut off this valve, which is going to our part, or to our pump. This is going to our part, and we would shut this off, and we would see no change, very little change. So we can see here, we have a small leak somewhere. So sometimes you think you've got a good bag, you do your drop test, okay, we've got a leak. Now we can come back, search a little bit more, listen a little harder, find where that source is coming from. We're here, see what we're now at 0.96, feeling a little bit better about that. We got a little bit more vacuum out of it. And when we turn this off, we're getting no movement. So we'll let this go for a minute or so and check back on it, and we'll see. Everyone has their own tolerances for drop test requirements. The smaller the part is, the more likely or more quickly any leaks are going to impact it. So I feel very confident with this. It's basically less than 0.01 bar in a few minutes. So at this point, we're ready to go ahead and do our infusion. Okay, now that our vacuum bag is pulled down, we've done our drop test, we're about ready to start our infusion. So last thing, we're gonna handle our resin inlet feed. So we're gonna do that the exact same way. Our resin inlet feed tee is ready. Wrap a little tacky tape. We've got our line prepped and ready. And then we'll take and puncture a small hole there and insert our bag. So again, you wanna be quick with this. Sometimes I'll just poke it and put my finger on it so I can set my knife down. And then there we go. Again, you always want to make sure that these are on there nice and tight. You don't want one falling off during your infusion. So I'll get my gloves back on so we can handle our resin and catalyst. Here we've got about 3,000 milliliters of resin here. It's important to note this is an infusion resin, so it's got the correct viscosity to be able to flow through the part. You can't use regular standard resin on infusion. You need a specialty resin. So we're gonna catalyze this at 1.5%. So we can go ahead and squeeze out our first 30. And then come back with just the right amount, another 15. So you're gonna wanna give this a nice consistent stir, making sure to scrape the sides and get a nice mix. You probably mix it for 30 seconds or a minute or so, especially in such a small volume like this. Things get mixed well. We've got good gel time on this, so that's one more nice thing about polyesters and vinyl esters compared to epoxy is you've got the ability to change your reaction time, and you've got a lot more flexibility on your mixture ratio, where epoxies, you got to be very spot on. So here we'll go ahead and put our hose in, and this is where the action happens. Once we turn this valve on, no going back, our resin will flow into our part. You can see how quickly it's moving through the anchor channel, and you can see the flow media doing its job. We can see in the branch feed method that the resin runs in very quickly to the ends of the anchor channel and then slowly fills in the space between the branches. So that's what those do, is they let it move very quickly and then space in together. There you can see the job of the resin brake doing its job. We'll see the way that the resin makes it very quickly to the ends of the flow media, and you can see it pretty rapidly stop right there. So what that's doing is it's two things, right? It's going to let the resin front fill out and make sure everything's totally wet throughout the laminate, and it's going to keep a good distance and a good amount of time before it reaches our vacuum line. You can see everything's starting to creep up around the edges. Everything's flowing well. Our spiral wrap here is communicating good vacuum around the part. One other general rule of thumb is, we want to leave our resin line open on our part. Even though we've reached the end of it, you want to leave that open, at least one hose, so that the resin can continue to creep into the part. Otherwise, you can end up in scenarios where you start to starve the part of resin through that vacuum process. So now that this part's completely infused, we'll leave it under vacuum, and I get asked the question a lot, when is it safe to take my vacuum bag off? Really, the general rule of thumb is once this resin has exotherm and the temperature has come up and then returned back down to about 10, 15 degrees of ambient temperature, you're good to go. You can turn off the vacuum pump. You can take out the bag and flow media. That flow media and everything's going to be a lot easier to take off while that resin's in that kind of green stage, as opposed to, if you wait overnight or longer, it can get really hard. And, you just got to spend a lot more physical energy getting it off of there. So really, that kind of wraps up the infusion process. I'm sure I've missed some stuff. So any other questions you have, fire them off in the comments. Check out all of our other content, NuWave Composites. We're on YouTube, Instagram, Facebook, TikTok. We got some stuff on LinkedIn as well. So go ahead and like, follow, subscribe, and check us out and let us know what else you want to see.